Welcome everybody. I'm Gianni Dalla Torre, as the Community Software Officer for the EGI Foundation. And I'm currently working with the Policy for Edge Cloud project and the coordination and delivery for the EGI Cloud support activities to the user community. Here are the housekeeping rules. Marco was just talking about that, so I will skip that slide. Today, I will give you an overview of what EGI is, our mission, and how our federation provides value for the broad scientific community. Finally, I will give you some insights about the experience we gained building our federation and the future challenges. So let's start. What is EGI? The EGI Federation is a pan-European infrastructure that supports a diverse set of disciplinary areas with the computing infrastructure that they need to deal with the massive amount of digital data produced in the experiments and collected from the sensor. From 2021, it will grow up to the 26 members, and Germany will become a full participant. The Federation is composed of providers from national and community initiatives, forming one of the largest distributed computing infrastructure for researchers. And just briefly, this is the list of participants of the EGI Federation and their logos. The vision of the EGI Federation is to support every researcher in Europe and beyond to have seamless access to services, resources like scientific tools, application, data, and the necessary expertise to be able to carry out scientific collaboration at global scale. And the mission given to EGI Federation is to deliver open solutions for advanced computing and data analytics to a growing community of scientists and innovators. When I speak about the Federation, that refers not just to the EGI Foundation, but to all the system of participants, which are the data centers in every country implementing our Federation. We are proud to see that the infrastructure is growing thanks to the national investment coming from our partners, but is also growing the interest and the need for scientific communication. And our greatest pride would be to see that, sorry, I have the postman probably. And our greatest pride is to see the scientific impact of our initiative, which is estimated to exceed 2,000 open access publications every year. As an open initiative with a global outlook, the EGI Federation also connects services providers beyond Europe, following the collaboration needs of the served communities. We support a set of diverse disciplinary areas, which includes finding new tools to diagnose disease such as epilepsy and brain tumor, supporting several COVID-19 related initiatives, the design of new frameworks to assess and reduce flooding risks, the search of gravitational waves by the LIGO Virgo collaboration, or pursuit the dark matter by the Xeon collaboration. EGI is also pleased to have enabled the Nobel Prize in physics. This is just a couple of pie charts that shows the distribution of our user community we serve. The figures on the right show the distribution across different disciplines, while the other highlights the type of initiative we support. You can see that several communities we work with are either in design, requirement, analysis, or piloting phases. EGI, in fact, is not just infrastructure and production-ready service only, but also pooling expertise across the member and the organization which take part of the federation. EGI delivers technical service and supports service at Europe and global scale, including high-throughput computing, cloud computing, storage, data management, consultancy, support, training, and co-development. What you see is actually the service catalog for the scientific community. Creating a federation is obviously about technology. We need to help integrate their services, and we also need to accommodate the different needs of our user community. As an example, the EGI check-in service solve the issue of the secure access to distribute computing resource placed under different organizations. And how it does it? It federates the local user's identity, delegating the authentication of the user's organization and the authorization to the user or to the resource owner. Moving the focus to the compute offer, as we say, the infrastructure is multidisciplinary, but is also multi-technology. EGI has, in fact, a long experience in high-throughput computing and grid computing, federating scientific institutes all over the world. This computing model has been developed by the higher energy physics community, and it's used in several other scientific disciplines. In recent times, it has enabled the Higgs boson discovery by computing the massive amount of data provided by the world's largest particle accelerator, the ELIXIR at CERN. At the same time, we support the initiative of a cloud federation with several cloud providers in Europe and beyond. The cloud federation is widening the number of service provided and supporting more technology and paradigms, from a pure infrastructure as a service based on OCI to a complete infrastructure, platform, and software as a service model, which is already supporting OpenStack, Docker, and Kubernetes. With our partners, we are also targeting several other paradigms like AI, machine learning, microservices, and service mesh. We serve a community of a multitude of profiles. We need to support both experienced grid ITC users and technology innovators, but also onboarding new researchers. For them, we have services like the notebooks, which is based on Jupyter Hub technologies and provide easy access to a computation environment in the form of software as a service, or better, a notebook as a service. But what we provide is just a more than technical service. There is also an important part of outreach activity, where we focus on training for information technology and service management. The EGI service management internally is based on FITSM, which is a lightweight framework for IT service management. It's established a set of practices that are used to design, create, deliver, support, and manage the life cycles and the IT services. And we are not only provide training for it, but we are using internally on a daily basis. Once implemented, one of the important advantages is that all the processes are virtually documented. That becomes a strategic access for new person joining the federation, but also to enable an efficient remote working. What we see are the services that federation offers outside, but there is also a multitude of internal services for the member of the federation itself, which enables the collaboration between different organizations and countries. I won't spend the time describing them, but I just want to show that the two lists have almost the same extension. I can say that sometimes EGI spends as much or more time on the business coordination activity than it does in technology. We have seen some of the services offered to the scientific communities and to the members of the federation. Here I would like to highlight the three pillars on which the federation is built around. One is the standards. Sometimes it's about defining new standards, while other times it's about adopting a suitable standard or recognize a technology as a de facto standards, and that implement the process and that implies a process of continuous research and update. Just to give you an example, what I mean, the EGI Federation provides services, FDB, which is a central repository of certificated multi-format virtual machine images. Building FDB was a necessity to allow interoperability in the virtualization layer. However, to provide the same type of interoperation nowadays for, let's say, Docker or Kubernetes container, we would not build a new tools and defining APIs and standard, but instead we would likely provide an hosted instance of tools such as Helm or Docker repository. Coming back to the pillars, the second pillar is the integration services. I'm sure I already spent enough time describing some of them, but I just want to stress the importance that we recognize to the open source as a way to be inclusive, taking, but also giving back to the broad community. As I said, our choice is to be technology agnostic. We are not choosing the technology, but we try to support the community requirements so that the federation can evolve in the way it chooses. And the last pillar is the coordination services. This really involves a large number of different activities and actors of the federation. Coordination is required from communication to technical activity, from community and project management to strategy, policy, and security aspects. All of them contributes and are actually necessary to provide professional managed services. I'd like to conclude my presentation with a few words about the challenges EGI is eager to engage to really drive the scientific community in the next few years. First of all, I would say more services and better services. As you know, hyperscalers are constantly increasing their cloud offer to the end user. What they provide is appealing because it enables an advanced service, easy to use and simple to access. While this is good and an opportunity, it is also a risk in terms of vendor lock-in, long-term reproducibility, fairness, data, and technology sovereignty. The experience of a federation approach is important to put together a sustainable alternative with the open source playing a central role in it. And we need to be careful, carefully balance the need to enhance the number of services we provide with the support and evolution of the old service. Clearly, it is not just a matter of good services, but also good documentation, reach out activities, and building community. The other big challenge that we need to face is the green computing. In such terms, actually, high throughput computing is efficient by definition. Using low priority queues, the batch system avoid the waste of computing resources, ideally keeping them always fully utilized. The natural limit of this moment is the trade-off between workload that requires vast computation, so computing centers add to balance between period with long and responsive cube or unused resources. The grid and the EGI Federation of ETC has been the solution for the national data center, sharing unused resources and overcoming the pitfalls of the spiky workloads. But today, we have the requirement to support more dynamic technology, which are not that efficient. So we need to deliver fast deployment to avoid paying economical and energetic costs. And that connects also to the last challenge. In a scenario where the constant increase of complexity and fragmentation is the norm, we've also to take advantage of the innovation that is happening at the same time. Promoting cloud-native approaches, strongly engaging automation, using tools for CI/CD, machine learning, infrastructure as a code, and so on. And all of these, balancing the resources we have and carefully embrace the right challenges. So that's all from my presentation. I give back the ball to Mark.
Okay, thank you, Gianni. Appreciate that. Very interesting presentation. So if you could pause your sharing, and I think we'd like to turn right now to Christian, if you could share his perspectives on these challenges in the world of Earth observation.
Yes, thank you. Then I will also turn on my webcam. So just a second. Just need to find the right button. Yes, so it's now working. Yeah, thanks a lot, and I like now to dig really into very specific topic. So EODC itself as an Earth observation data center. So our ambition and goal is really to collect and provide data of the Earth system in general. So our ambition is to provide data, but also the respective compute resources in order to handle this huge amount of volumes of data that we need to collect and to provide in order to allow to analyze the past of the Earth, but also to predict its future based on past and current observations. Yeah, as you already mentioned in the introduction, EODC itself is located in Austria as one of as an initiative that has been started in 2014. with a public-private partnership model. So EODC shareholders are partly public organizations. It's, for example, the Technical University in Austria, in Vienna, and the Austrian Med Service, but also private companies that are just fostering this idea of building up a data center dedicated for the use of Earth observation data, serving the public and the private sector. So therefore, from the very beginning, this collaboration for the public and private sector was very important. And what we're aiming in is setting up joint IT infrastructure. So we have quite a number of infrastructures available in Austria. But what we do is we expand this infrastructure in a manner that it facilitates the use of Earth observation data. So for example, we have quite a large supercomputing facility at the university available for researchers to process and analyze their things. But what we as EODC did, we established next to it a large storage system, so that next to the compute facility, the researchers, but also the public and also the private sector has access towards this large storage repository where raw data is available that can then be further analyzed for long-term time series studies, for example. So therefore, that operation and that joint availability of research and generic infrastructure dedicated built for Earth observation data was one of the very initial pillars of EODC. Yeah, and last but not least, we are very aware that especially Earth observation, there the bridging between the science and application is very important. The sector is really strongly driven by public interests and also by scientific challenges. Still, the practical applications lag behind, and EODC also wants to act with its role as connector between science, the public, and the private industry, really bridging the practical application for Earth observation data in general. So that's really our main ambitions from the very beginning. We started in 2014 just with one person, so I have been the first employee. And step by step, we managed to acquire more interests, acquire more national and also international projects. We are now already more than 20 people really dedicated on the establishment and operation of the EODC data infrastructure. Yeah, what do we offer? We have, as I mentioned, a large storage system in order to provide these huge volumes of data. The storage system, this raw data is growing with more than 2 petabytes a year. So that's really quite significant. The system is on one hand connected to the HPC facility of the university that can be used for the researchers, but we are also allowed to provide it towards private industry and also towards other public organizations. And the system or the storage is furthermore connected to a cloud computing environment towards, in our case, also OpenStack, that can be further connected towards further international activities like EGI. So we are also working there in the EOS Cup project, connecting also EODC's infrastructure into that direction and bringing our services into this bigger, wider European view. Yeah, so that's, I would say, the main service of EODC with a strong focus on data and also the real provisioning of the data in an adequate manner. Yeah, what do we store? We store Sentinel data from the very beginning. So in 2015, the first Sentinel satellite delivered data. From that time on, we are starting to acquiring globally Sentinel-1, Sentinel-2, and in the meantime also Sentinel-3 data. We don't store all the products like some other initiatives that have been created in Europe. We have a very dedicated focus for certain specific data sets where we have the experts on board and where we also think that on the long term it makes sense to store these data sets in a long-term archive that can be processed and can be reused for the long-term analysis. So that's somehow the status from beginning of September. We already reached at the moment already more than 8 petabytes of data, of raw data that we are serving for this long-term global archive. As you see, at the beginning, we had some discussions with data sets, shall we store satellites were coming in a step-by-step manner. I would say since mid of 2018, we basically have fixed our data acquisition schema. It's more or less linear. And based on these 3 sensors, the volume is, as I've mentioned, growing something like 2 petabytes a year with the current selection Sentinel data. Next to Sentinel data, we also have a focus on other data sets that contribute to the analysis and that are requested by our users and customers in order to make advanced use of the satellite data. Yeah, so that's the data repository. We are acting really in a close, bigger cooperation network. So on one hand, we have long-term partners that you can see here on the left under the principal, and the associate partners that are organizations with a long-term commitment towards EODC and consuming services in a constant manner, and that can be extended on an on-demand request. So I think that's very important. We have Austrian actors, but we also have international partners around companies, but also universities and research organizations that are really that are regularly active within EODC. So there's the idea really to think beyond individual research projects or project activities. It's really a long-term partnership that we have established here. Next to it, on the right side, you see our general federation partners, where we really, from the very beginning, had a very strong focus being an entity that is federating towards others. We were always aware that Austria will not solve the whole problem in Earth observation, providing enormous volumes of processing and data. So we were thinking from the very beginning to be part of a federated entity. For that ambition, we on one hand are federated within the European Open Science Cloud, being active there. Austria is also currently trying to become an official member of EGI so that we can act and work there also more and more together. We currently have quite a number of current and future research projects where we bring in our competence in Earth observation towards this idea of the realization of the European Open Science Cloud. We are also acting within the Earth observation community within the EODC that is established by EUMETSAT, ECMWF, and Mercator Ocean, so public entities, where we have attached our data center and our data provisioning service so that this can be enriched by our services, and we also gain input and momentum from the services that are provided by the EODC. So that's quite active collaboration already started in 2018. And then last but not least, the network of resources that is established by ESA as one marketplace where actors in the field of Earth observation can host their services and where the services can also be procured and used for research activities within ESA, but also beyond ESA activities. Yeah, so that's this wider cooperation network. So we are doing a lot of projects and activities together with the partners that are listed here, but also significantly beyond this. And I really think that this is a very fruitful network that is helping each other to expand and also to promote further their ideas. Yeah, for today, I want to present you basically two quite new activities that EODC is performing. On one hand, it's the ESA project OpenEO platform. As you see here at the left side, there ESA had the idea to build something similar like the Google Earth engine. So a very easy to use interface for researchers, but also for the public and private sector to be used in order to analyze Earth observation data. And we had a precursor project called OpenEO, where we already had, independent of this ESA idea, the concept around to federate different providers for Earth observation data, to provide them the joint offer with identical user interfaces for the different providers in order to make use of the code that is developed on this infrastructure, but also on the other infrastructure. And with OpenEO platform, this is now really transferred from a research project, the idea that was realized in Horizon 2020 towards an operational service, where we want to provide this platform towards the scientific world in the first step, but also then later on towards the private industry to make really use of one joint interface that in the back facilitates many different platforms that can be used to speak with one language and to also initiate data access, but also compute power. So that's where OpenEO platform is located, and that was kicked off in September, and we have the very big ambition to provide a first operational prototype service already in February next year. The second thing that's called Cscale, it's the Copernicus EOS analytics engine that will be a quite new Horizon 2020 project that will start beginning of next year, with the idea to enrich EOSC and its portal with scalable big Copernicus data analytics services. So here we really do the step that Earth observation data, but also infrastructure will be integrated in the EOSC offering. And I'm really happy that we can establish this together with EGI, but also as a number of other partners, so that we can make this Copernicus service visible within EOSC by that activity. Yeah, so the activities have a little bit similar ambitions, but on the left side, it's really the focus to the EO community and really a dedicated service with a common language and interface. While on the right side, the big focus is really enriching the EOSC portal with scalable services and connecting the EO community also with other e-infrastructures that are available within EOSC. And I think, therefore, it really makes sense to have both around in parallel to, on one hand, enhance the EO side, but on the other hand, to be able to integrate the EO offering and the EO service into the wider context of the European Open Science Cloud. Yeah, OpenEO, I mentioned it already before. Initially, it was a Horizon 2020 project that was led by Theo Min under the EO Big Data Shift call. It was extended till end of November 2020, so it will end beginning of next week. And we transform basically this research idea now towards this operational service that we realize is a number of partners within the ESA contract, that this service then shall be available for users. Yeah, the principle of the architecture, so we build on top of an infrastructure layer that can be some of the dioceses or other ESA resources on national scale, the European Open Science Cloud, OCRE, but also other providers. There we build a backend layer on top of it that basically speaks the OpenEO language. And then towards the user, we provide JavaScript, Python, and R clients to access the data and also the processing facilities. We also have a web editor for nice and simple setup of processing services for EO. And we have a Jupyter Lab interface to interact with via the OpenEO interface towards the different providers. So that's the high-level overview of this activity. We have a number of use cases to be performed during the project lifetime of 2 years. So already at the first 6 months, we have to deliver the first use case, and then this is expanded further to the end. And the number of use cases is growing as the service will become more and more mature. Yeah, Cscale, on the other hand, is something that we are just proud to kick off beginning of next year with a budget of 2 million, where we have also 500,000 euros for virtual access available, so that really some research ideas can be implemented from other organizations within that Cscale activity. Yeah, the idea is to really bring together the EO sector with the e-infrastructures. That's also why the partners within the project activity are included from both sides. So it's the EO people, but also in infrastructure, so that we really can establish a very good and close link towards the European Open Science Cloud. Yes, and we have the big aim to enrich the EOSC and its portal with the scalable big data Copernicus analytics services. Yeah, the objectives, I think I touched them roughly, but what we want to do is to integrate to EOSC, to have focus on the FAIR principles, focus on federation, focus on the policies, focus on AI and accounting procedures, and to really maximize the interoperability with other EOSC services. So that's one of the main ambitions of that project. Yeah, as this project is new, I don't have further details for this one, and also time is off. At the end, I just want to provide you the contact information of EODC, and especially the links towards the OpenEO platform. So if you're interested, you can follow us either on Twitter, or you can also subscribe towards a mailing list that we're hosting, so that you get updates and that you can follow these ideas of OpenEO. Thank you very much for your time and listening.
Christian, thank you so much. That was that's fascinating and really a huge amount going on there. I hope we will come back to ask some questions, but I wanted to turn our attention right now to Jonathan's presentation about ELIXIR. And if you could, Christian, if you could pause your share, and then Jonathan, if you could start your share, we will hear your exciting story.
Okay, hopefully, hi everyone, hopefully you can see that okay.
Looks good.
Okay, great. Yeah, so thanks for inviting me. I'll try and just briefly introduce what ELIXIR is. I think many people may not be so aware of that. We're an infrastructure built through a European-wide member state organization. So it's a very similar model, legally speaking, to the European Molecular Biology Lab. And we're co-located in Cambridge in the UK alongside the European Bioinformatics Institute. So the important distinction there is that we're still a European entity because it's a separate structure, government treaty organization, separate structure to the EU itself, although obviously we work closely with our EU partners and also globally. And hopefully you'll get a sense of that as we step through these slides. So our mission is all about operating, trying to make sustainable this huge diaspora, as it will be in all disciplines. My original background, by the way, is in research astrophysics for many years, and that's how I learned all about data mangling, analytics, and so on, and got more and more interested in how you could address those challenges in life sciences. So we're trying to refine that landscape that enables secure data sharing. But as we all know, there's no way to do that at scale these days and access powerful compute resources unless you tackle cloud allocations, deploying containers across hybrid cloud resources in our case. So I think one area of distinction from some of the other infrastructures is that our core in ELIXIR is as a member state organization, we coordinate the services, the activities, the resources, cloud computing resources, for example, from across this large number of nodes across Europe. So we don't, as it were, run an infrastructure from the center ourselves. We coordinate the provision, working obviously with standards and fair data principles across our nodes and with our partners. So obviously there's a strong genomics focus to that, and we also work hard on how that can be translated and made useful more broadly with industry across the bioeconomy. So as I say, we're the hub based in the UK and Cambridge. Within each member state, there are many individual universities, institutions that might be affiliated with that so-called node. So there are approximately 23 nodes. It's a slowly growing number of nodes. We have associate partnerships and strategic partnerships outside Europe also. So I'll come back to that in a moment. But as I say, across those 23 nodes, founding nodes, if you like, there are about just under 400 institutions affiliated. And we, although we don't run most of the services that I'll speak about, we coordinate those and we do commission projects and services in order to federate those and to make use of those. So the kinds of challenges in particular we try to address are sort of shown here in terms of human genomics and translational data. So that's obviously a very big area of focus for us. And that's through things like data discoverability through the Beacon project, and that's a driver project within the Global Alliance for Genomics and Health, where ELIXIR has the first strategic partnership with that global body in all sorts of, because we collaborate and work on so many different areas of standardization, including cloud and AEI, which is a the ELIXIR Cloud and AI is a separate driver project in itself within that body. We also help maintain the resources run by European Bioinformatics Institute that maintain things like the European Genome Phenome Archive, and that's come into its own, in particular in the last year, in support of much of the science work that's been happening around the COVID-19 pandemic. And as I was saying, through these technologies and services, we're trying to enable that federated data access and indeed data analysis. And we coordinate and help run large grants, including European grants, in order to achieve that in a human data context, for example. So the treaties such as the Beyond 1 Million Genomes or the 1 Million Plus Genomes treaty signed internationally, we've won European funding for a Beyond 1 Million Genomes project, which basically helps coordinate that activity. So I'll pick out a couple of the platforms in ELIXIR. There are 5. I'll just quickly go back. So that's data, training, compute, interoperability, and tools. I'm just going to say just one slide each on a couple of the platforms, just to highlight the importance of them and why we need this enabling cloud infrastructure in order to access them. So we have so-called core data resources, which are really the bedrock of what we do. But some of them are very large. Many of them are public. And these are core data resources around, as I say, EGA, the European Genome Phenome Archive, and so on. These are resources which many, many researchers across bioinformatics need to use, as well as whatever source data sets they're working with. And they typically might need to run them in high-end compute resources and compare them against their own data sets. So this is where the compute platform starts to come in, because we make it possible to co-locate those data sets in a simple way for scientists, without the scientists needing to go through all the difficulty of trying to work out which individual service they should access and so on. And then we also co-locate and make available key sets of tools and resources that they may need to run in those places. So that includes biocontainers, which is a sort of registry of bioinformatics containers, software containers. Bio.tools, which is the first, which is just a large registry of tools, workflow tools in general, but is a useful resource for bioinformaticians. There's facilities for benchmarking that. And then Galaxy is probably the largest individual community of analytics platforms. It's based around R statistical analysis and Python, but also the CWL Common Workflow Language Standard. So coming to compute and cloud more specifically, most of this I've already said. I think 2 of the key ways we achieve our goals in enabling this distributed federated access is through key tasks in our platform in compute around establishing and implementing computational standards. So that's the bottom point around Global Alliance for Genomics and Health Standards. Say a couple more things about that in a minute. Infrastructure services registry, container deployment at scale, storage and data transfer, as I say, in order that people can work on these data sets in one place. And probably the most important, and our first ELIXIR infrastructure service, is based around authentication and authorization. So on that, in a bit more detail, this is one of the things we're best known for. And indeed, this ELIXIR AAI solution works using common OpenID Connect and other standards, but importantly, we are increasingly working with international partners, and have done for many years, including in EOSC, European Open Science Cloud, to enable that across infrastructures. So not just within the many nodes of ELIXIR, but how can it work alongside a wider range of life science infrastructures. And the benefits of that should be obvious in terms of reduced bureaucracy and costs and so on. But this is essential if you're going to provide federated cloud services. As soon as you get away from purely public data, what these solutions for identity management enable is that you can use your institutional credentials to access data sets that may or may not be public, or that may be part of a sort of research collaboration prior to wider public dissemination. So there are many groups, as you can see, already using those services. And as I was just mentioning, there's a current EOSC Life project, so that's the European Open Science Cloud Life infrastructure that brings together about 15 biomedical science and life science infrastructures. And we're developing the so-called life science login, which builds on ELIXIR AI, but also with solutions from our many partners, Scale, EGI, and of course, individual biomedical research infrastructures such as BBMRI and others. So what we've done is, again, using those common standards that have been developed over a number of years now, with adapting the ELIXIR AI solution to work alongside those, the other requirements across other infrastructures, so that we have a common login to these cloud services. And taking that one step further, we've built upon that to enable this Global Alliance for Genomics and Health passport standard. So alongside Google, ELIXIR was the first implementer of this GA4GH passport standard at the end of last year. And these are ways of enabling even broader work and partnerships. As you can imagine, when you're responding to a global pandemic, for example, you need that international cohort access potentially enabled by these kind of solutions. So coming to cloud more specifically at the end here, a key requirement for us is how do you deploy reproducible containers and workflows across these national cloud environments. And as many of you will know, in many ways, it's not the technical standards that are most difficult here, although obviously there's a lot of technical expertise, which you won't always have in any one institution. And so how can you spread and share that cloud computing expertise? But the governance issues are particularly challenging. This is where we really work hard to integrate these identity management and cloud solutions to make this possible. So the standard problem, I think, is how you resource all of this. And the EOS Life project is also working on this. How do you, and including commercial partners, by the way. So how do you resource a researcher so that they have relatively seamless access to resources? How do you basically pay for that in each of the different nodes that provide the services? How do you pay for that in an environment where in research, typically it's, start, stop project funding? How do you get a more kind of financial services approach to resourcing that? That's a key challenge, I think, for all of us in the future. So a nice example of that kind of work was a particular driver project, if you like, in the Global Alliance for Genomics and Health, called the FASP project, so the Federated Analysis Systems project. And here we were really chuffed to work alongside 3 other commercial providers in this space, because obviously there's a lot of pharma industry and related involved. DNA Stack, Terra, 7 Bridges, we all basically had to work on the same data set and produce the same results for a genome-wide association study using a public data set of 1,000 genomes. And we were able to run exactly the same pipeline using, in our case, all 5 of the available cloud standards and identity standards, basically on a rare disease public data set. How can we run that across 5 different ELIXIR nodes? And we were able to do that successfully. So each stack has their own infrastructure and their own implementations of the APIs, but by using these cloud standards, you can make it possible to run the same data set and get the same results in 5 different node services. And so this is a key building block that we hope to to be able to build on and use in these large-scale genomic studies that are increasingly on the agenda now. And then finally, just a little bit more about how we were able to use these cloud resources to support COVID-19. I'll be quick now because I've just realized the time. So there's a web page here where you can see the kind of resources, not just cloud computing, but in particular around cloud computing. We were able to facilitate and enable this European-wide COVID-19 data portal. So the portal is hosted by the European Bioinformatics Institute, but ELIXIR was a key coordinating partner in bringing together the many different actors. You can see in the middle there this large number of key data sets which were required for the analysis. And it's all about how do you build that trust alongside the technical solutions and infrastructure. And we ended up with this kind of data hub around SARS-CoV-2 that then working alongside the Federated European Genome Archive enables us to provide this COVID-19 data portal at the end there. And you can kind of see the success of that over the last year, starting in January. With the launch, even by April, we'd got a first iteration of that platform available, bringing together many of these cloud computing resources, as I've mentioned. And increasingly, you can see how additional resources were added. Some of them came later because of their size and complexity, for example, the EGA. But as you can see there, of order of 500,000 records now available for all scientists across the world using and working on these resources in support of the pandemic. So I'll finish on that note for now, thanks.
Thank you so much, Jonathan. That was a great presentation, and I know a quick tour, like all of you, a very complicated undertaking. We have just literally a couple of minutes for questions. I'm wondering if anybody in our session has a question that would like to pose it. You can raise your hand and ask verbally or put it in the chat. And while we're waiting for people to figure out what they want to ask, I have a question for each of our three contestants, and that is, so you've probably seen a bit of language, a bit of words. We've heard from Pierre Chastanet this morning about data spaces. And you guys, you folks are old hands at data spaces. So what's your one message to the European Commission about how to do it right, given your own experience in your respective worlds? Christian, maybe we can get a view from you.
Yes, I can give a try. So I think what is very important is to bring together data and experts, because in order to have really a long-term sustainable data provision, you really need to have the experts that are enabling and providing a means to the data. So it's not really just infrastructure and disk storage and tape storage to really store data. You also need to have the expertise around, because especially in our field in Earth observation, you always have to reprocess data with new algorithms, with new data that is coming in. You have to align the data sets over decades. So it's really very important to really bring expertise and data together. And that's, I would say, one of the most important things that I would see.
That's a great point, Christian. Thank you. Jonathan, do you want to offer a quick point of view? We actually are out of time, but I hope you'll add something.
Yeah, I do apologize. I was just replying to an individual message in the chat, a question from someone in the audience. No, so just perhaps go to the other person and then come back to me. Sorry about that.
Okay. Gianni, can you offer a point of view on that?
Do you ask me? Sorry, I have a question. So yeah, if it's me,
any learnings from EGI that might apply to the European data spaces?
I would say that we should try to improve the experience that we have with that kind of tool that allows the access to the computer resources like the check-in system or the AGI, the ELIXIR AI, to be expanded also to the data space, creating a sort of full identity and access management system. So you really have something that is separate from your data sets, and is something like a standard, and you develop that as a technology, and you can apply to different type of communities. So
okay, that's great. Thank you, Gianni. Jonathan, can you do you have a 30-second answer?
Yeah, I think really it's through building the European and global standards in researcher identity, data discovery, those global alliance standards in our case, that's a sort of a key way. And by the way, although it's specific to genomics and health, that global standard setting body, it's wherever possible, we're reusing international technical computing standards. It's not under the hood, so to speak. So these are fully compatible across infrastructures as well. And indeed, we have to do that in an EOSC context as well, where we're specifically trying to work across the infrastructures. I've done some work myself in research in the past on environmental health challenges, and that was very much having to work with cloud Earth observation data in terms of pollutants, and how do you match that to respiratory health data. And so I know well the importance of trying to work with standards that can work across the domains as far as possible. But typically they do need a particular implementations for a given domain, which is what we obviously spend a lot of time on.
Right. So there is a question in the chat. It's from Jerry Delamar. I'm actually not going to give us time to answer that. I'm going to ask Jonathan to respond directly to Jury, and I'll connect the two of you later. I've got somebody behind me with a stick who's saying, get them out of your room, get them into the plenary. And so I'm going to try to post where the heck is it? the coordinates for the meeting that you're supposed to go to. And here we go. Just bear with me.
I should have shared it.
I'll post it in the chat. If somebody hasn't beaten me to it. Oh, there you go. You beat me to it. So thank you very much. Thank you, Gianni. Thank you, Christian. Thank you, Jonathan. These were really good presentations. And I think it really does highlight the fact that the research community knows a thing or two about data spaces, working together, et cetera. And we hope that the rest of the cloud community maybe asks about how to do it, get some advice. So I look forward to seeing you in the wrap-up session. And thank you very much, and have a great day.